This is Sarah Broninger of the New Horizons Academy, and this is the first of the videos on linear equations. The first thing you will see is some definitions, and then the video. I'm going to start the subject of graphing linear equations with some definitions. A graph is a mark. Graphing is drawing. So this is a graph, and it has a name that tells you where that graph is. The name of that graph is the coordinate of the graph. The coordinate are the symbols or words that tell you where a spot is. The graph is the spot. Cartesian means this type of grid. It was designed by a man named Descartes, so it's called Cartesian. Linear means of or about lines. We're going to learn how to draw lines on our Cartesian grid. An equation is a math sentence that has an equal sign in it. So if I gave you something like this, that is an equation. Cool? Okay. The first part is spots. This is called the x-axis. This is called the y-axis. This is the x line that shows you the left-rightness. X is left-right. This is the y line that shows you the up-downness. That is a nice bit of stable data that will always be so in all graphing. Y is up-down, x is left-right. If I want to say where that spot is, I could talk about its left-rightness. It's 3 spots over, and its up-downness. It's 1 spot up from this spot. This spot is called the origin. It's the center. It's the anchor point that everything is described compared to. One way that you could do this is you could say that it is on x, it's at 3, and on y, it's at 1. You could take a line. I use rulers. On x, it's at 3. On y, it's at 1. It's right there. When these are written, they always write x first and y second. They don't bother writing that this is x or this is y. It's always written in that form. So, -4, -3 would mean that on x, it's at -4, and on y, it's at -3. It's right there. That is how to graph, make a spot, coordinates, the words that tell you where the spot goes. Now I'm going to graph lines. A line is written as an equation. It's an equation because it has an equal sign, and it's saying that this is equal to that. You can also think of this is what you have to do to get that. So a line goes in both directions forever. If this is your line, you could think that it will hit every x somewhere. So it's true, if this line goes on forever, that every x you could come up with, -2, -3, -4, and on, 3, 4, 5, 6, and on, is somewhere on this line. From that viewpoint, you could do this. Any x you choose is somewhere on this line, so I'm going to choose those at random. I choose them because they're right in this area. So seeing as it's true that there is a -2 somewhere on my mystery line, I could put it right here. -2 times 2 plus 3, which is -4 plus 3 is -1, gives me my y. Because this is what I have to do to x to get my y. So I have my first set of points. On x, I'm looking at -2. On y, I'm looking at -1. -1 is somewhere on this line. -2 times -1 is -2 plus 3 is 1. So I'm looking at -1, 1. 0 is somewhere on this line. 2 times 0 is 0 plus 3 is 3. So I've got 0 and 3. 1 is somewhere on this line. 2 times 1 is 2, plus 3 is 5. Now I have a line. So you can draw a line by listing every single point on the line, which takes too long, or you can write the equation of what you have to do to x, I have to do this to x, to figure out y. This is a description of the line, and the nice part about this description is this will work anywhere, not just in this area where you can see it. You can use it for finding points way out there. There are other ways to graph lines, and I'm going to do those in the next video.